Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now if you find my videos interesting and important to your studies, also please don't forget to subscribe. So this is a portion of distributed forces. So still on locating centroids of volumes, areas, arcs or lines, and the corresponding derivation of formulas for volumes as well as for the locations of the centroids or center of gravity, which is very important in the succeeding topic on uh, beams subjected to loadings, line loads, concentrated loads, or surface loads. Level 71. Determine the y-coordinate of the centroid of the volume generated by revolving the shaded area of the right triangle about the z-axis through 90 degrees as shown in the figure. So here's the figure, and let's consider the slab shown, which is a quarter circle. Radius is x here along y, but x equals y because this is a quarter circle. The thickness is dz. So that's the centroid, and that's y. This is also x. This is also y, but y equals x, of course. And this is dz. And if we draw it here so that we can analyze the location of the centroid, because this is a quarter circular arc, circle rather, the location of the centroid is 4r over 3 pi or 4y over 3 pi from the figure. So y sub c is 4y over 3 pi. So differential volume is volume of this element, which is pi over 4, area of circle, quarter circle, pi over 4y square, then times the thickness dz. Where this is z, so that is z, therefore this is b minus z. So by similar triangles, y as to b minus z equals h as to b. So y is h over b times b minus z. Substitute here. Volume equals pi over 4 integral of quantity h over b, quantity b minus z square dz. Then from 0 to b. Limits. So volume equals pi over 4 h square over b square, then negative quantity b minus z cube over 3 from 0 to b. Integral of b minus z square is negative b minus z cube over 3 from 0 to b. So substitute negative pi over 12 h square over b square, then z 0 cube minus b cube. So the volume is pi over 12 bh square. Then applying Varignon's theorem, volume times yg equals integral of y sub c dv, where y sub c is 4y over 3 pi. So pi over 12 bh square yg equals integral from 0 to b of 4y over 3 pi, then dv is pi over 4y square dz. So simplifying, pi over 12 bh square yg equals integral 1/3 integral from 0 to b of h over b minus z quantity cube dz, wherein this is equal to y because we have y cube here. Then the integral, so pi over 12 bh square yg equals h cube over 3b cube, then negative b minus z to the 4th over 4, the integral of b minus z cube dz. So substituting pi over 12b after we cancel out h square, yg equals negative h over 12b cubed, then upper limit 0, b minus b, so 0 to the fourth, then b minus 0, so minus b to the fourth. So pi yg equals negative hb to the fourth minus b to the fourth, quantity 0 to the fourth minus b to the fourth. So this is positive h over pi. Yg is positive h over pi. So that's Yg. Level 72, determine the coordinates of the centroid of the volume obtained by revolving the shaded area about the z-axis through 90-degree angle. So here's the figure, and if we consider a strip, vertical strip, distance x, then this is also x because this is circular. So this strip here generates a surface area, and it appears as an arc if you look at it from the top. The thickness is dx, the height is z, and that's the distance traveled by the centroid of this z here. So that's the centroid, and the distance from the base xy plane is z over 2. This distance is also x, which is equal to y. Then that's z over 2. This is x sub c, and this is y sub c. So that we can analyze from here. So this is the z, dx, z, and AA. So this is also a, therefore this is x, this is a minus z. So that's x, a minus z. So dv is z dx, the area of the strip z dx, times distance traveled by the centroid, which is this, which is equal to radius times angle, which is pi over 2, because the angle is 90 degrees or pi over 2. So it is area of the strip, this one, z dx, then the distance traveled by the centroid is the length of this arc, which is radius x times central angle pi over 2. So volume therefore equals pi over 2 integral of xz dx. So from this triangle, x squared equals a squared minus, or x squared plus a minus z quantity square equals a squared. So that means a minus z quantity square is a squared minus x squared. Extracting the square root, a minus z equals square root of a squared minus x squared. So that means z is a minus square root of a squared minus x squared. So substitute here for volume. Volume is pi over 2 integral of x, then z a minus square root of a squared minus x squared. So pi over 2 integral from 0 to a of x times quantity z, which is a minus square root of a squared minus x squared dx. So volume equals pi over 2. Then we have ax, the integral is ax squared over 2 from 0 to a. Then minus pi over 2 integral from 0 to a of x square root of a squared minus x squared dx. So let's concentrate here. Let u be square root of a squared minus x squared, or a squared minus x squared to the 1/2. This is, sorry, let u be a squared minus x squared. The differential is negative 2x dx. We already have x here, x dx. So we introduce 2. So this is pi a cubed over 4 then plus, let's make this plus pi over 2. Then I introduce 2 here because x dx is also multiplied by negative 2. So remember, the original sign is negative. So that's the negative sign. So that this integral is in the form u to the 1/2, and this is the differential. So therefore, this is u to the 3/2 over 3/2. So volume is pi a cube over 4 plus pi over 4. Then we have u a square minus x squared to the 3/2 over 3/2 from 0 to a. So substitute, volume equals pi a cube over 4, then plus pi over 6, 2 pi over 12, so pi over 6, then upper limit, a square minus a square, so 0, then minus lower limit, a square minus 0 square, so a square to the 3/2 is minus a cube. Combining, so volume equals pi a cube over 12. Then by Varignon's theorem, x sub c is equal to y sub c, which is equal to 2x over pi, the centroid of an arc, because if you look at it from the top, this generation, the generation of this arc or of this strip appears to be an arc. So the centroid of the arc is 2 times radius over pi. In this case, the radius is x, which is equal to y, so x sub c equals y sub c, 2x over pi or 2y over pi. Substitute, while g sub c is z over 2 only. So pi a cube over 12, x sub g equals integral from 0 to a of 2x over pi. Then differential volume is from here, pi over 2 xz dx. Simplifying, pi a cube over 12 x sub g equals integral from 0 to a of x squared times z, and z is a minus square root of a squared minus x squared dx. So the first integral is ax squared, so the integral of that is ax cubed over 3. So pi a cubed over 12 x sub g equals ax cubed over 3 from 0 to a minus integral from 0 to a of x squared square root of a squared minus x squared dx. So let's focus on this integral here. Let x be a sine theta, because here we have constant square minus variable square. We put the variable a sine theta. Dx is a cosine theta, d theta. And we form a triangle defining x equals a sine theta. So if this is theta, opposite is x, hypotenuse is a, then this is square root of a square minus x square, which is a cosine theta. So I2 equals this integral here, integral from 0 to negative integral from 0 to pi over 2, because when x is 0, theta is arcsine of 0, so 0. When x is a over a is 1, so arcsine of 1 is pi over 2. Change limits. So we have x squared, which is a sine theta quantity square. Square root of a squared minus x squared is a cosine theta, and dx is a cosine theta d theta. So I sub 2 is negative a to the 4th. Then this is sine square, cosine square, sine square theta, cosine square theta, d theta. And since the limits are from 0 to pi over 2, we use Wallay formula. So for sine square, so the first entry here is 2 minus 1, power minus 1 of sine, so 1. Then we stop. Then for cosine, cosine square, so 2 minus 1 is also 1, then we stop. Then the denominator is the sum of the powers, so 2 plus 2 is 4. So 4, then decreasing by 2, so 4 minus 2, so 2, we stop at 2. Remember, from Wallay formula, we either stop from 1 or 2. Then because both 2 and 2 are even, so we multiply the result by pi over 2. So therefore this is negative pi over 16 a to the fourth I2. So pi over 12 a cubed xg equals a to the fourth over 3 minus pi a to the fourth over 16 from this result. So simplifying and solving for xg, xg equals yg equals 4 over pi. So 12 divided by 3 is 4. Cancel a cube. Then divided by pi. Then 12 times pi over 16. That's negative 3/4 pi divided by pi. So 3/4. So that's how you have negative 3/4 here. Then for g sub z, pi over 12 a cubed g sub g, z sub g equals integral from 0 to a of g sub c, which is z over 2, then differential volume pi over 2 x z squared dx, x z dx. So pi over 12 a cubed z sub g equals pi over 4 integral from 0 to a of x z squared dx. What is z in terms of x? It's here. So g sub g is, after we cancel pi 12 over 4 is 3. So 3 over a cubed. Integral 0 to a of x, then z squared. So this is z a minus square root of a square minus x squared quantity square dx. So expanding g sub z is 3 over a cubed. Integral from 0 to a of x, then a square minus 2a square root of a square minus x square plus a square minus x square after we expand this raised to 2. So combining, we have 2a square x, the integral is so 3 over a cubed, integral from 0 to a of 2a square x minus 2ax square root of a square minus x square, then minus x cubed dx. G sub z is 3 over a cubed, then this is a square x square plus a, remember the integral of this is a 2/3 a square minus x squared to the 3 halves, then minus integral of x cubed is x to the 4th over 4 from 0 to a. Substituting limits, we have g sub z equals 3 over a cubed, quantity a to the 4th plus 2/3 a, then 0 minus lower limit a cubed, so minus a cubed, then this is minus a to the 4th over 4. Of course, after we substitute lower limits, we have finished this, then this 0, this is also 0. So combining and simplifying, g sub z is equal to a over 4. So that's it for this problem, challenging problem. Level 73, determine the coordinates of the centroid of the truncated cylinder which is taken from a pipe of constant small thickness t. So actually we can locate the centroid of the surface area, which is the same as that of the cylinder of constant thickness, because the volume of the material is simply surface area times this very small thickness. But let's consider the general case, assuming the thickness may not be constant. So let's just consider the volume of the element, although volume is surface area times thickness. So let's have a strip shown. Then this is d theta. The height is y. So that's d theta. The radius is r. And this is theta from the x-axis towards that differential element for d theta. So that is y. This is r d theta, the length along the curve or circular path, r d theta. And remember the thickness is t. So in this view here from the y-axis, so this is x, this is the top view of that differential element. So r d theta, the thickness is t, and the height is y. So that this is x, which is r cosine theta, because theta is here. So x is x sub c equals r cosine theta. Then this is z, which is g sub c, and it is r sine of theta. So differential volume is area of the strip, which is 2 times, because there are two portions in this positive z direction and in the negative z direction. So we multiply the differential volume of the element by 2. So the width or length of the strip, width of the strip is r d theta, the height is y, and the thickness is t. So that's the expression for dv. So to relate, because this distance is x, that is x here, or this one, and therefore this is r minus x. So y as to r minus x equals h as to 2r. So y as to r minus x equals h as to 2r. So that means y is h over 2r, quantity r minus x. Substitute here. So volume equals 2r, 2 times r d theta, then y h over 2r r minus x times t. So volume equals 2r, or cancel 2r. So we have ht, then integral from 0 to pi, theta is from 0 to pi, then r minus x d theta. So from the figure, x is r cosine theta from this triangle here. This is theta. So therefore, this is r cosine theta, hypotenuse times cosine of that angle. So volume equals ht, integral of 0 to pi of r minus r cosine theta d theta. Factor out r. So volume equals ht r, integral from 0 to pi of 1 minus cosine theta d theta. So that would be integral of 1 d theta is theta, integral of cosine is sine theta. So volume equals ht r, quantity theta minus sine theta from 0 to pi. So remember, sine of pi is 0 and sine of 0 is 0. So pi minus 0, so this is just pi. So volume therefore is htr times pi, or simply pi rth, or pi rht. So that's the volume. The surface area therefore divided by t is pi rh. So that's the expression for surface area. The centroid of the surface area, as long as the thickness is constant, is also the centroid of the volume of this element. This surface, when multiplied by thickness, becomes volume. So by Varignon's theorem, volume times yg equals integral of y sub c dv, where y sub c is just y over 2. So pi r ht yg equals integral from negative from 0 to pi, or from negative r to r, of y sub c, which is y over 2. Then dv is 2r d theta yt, cancel 2. Simplifying, pi r ht yg equals rt integral of y square, so h over 2r, quantity r minus x, quantity square d theta. Expanding, pi r ht yg equals h square over 4r, h square t over 4r. Then we have r minus r cosine theta, quantity square d theta. So we have r square here, factor out. Pi r ht yg equals r h square t over 4, integral 0 to pi of 1 minus, expanding, 1 minus 2 cosine 2 theta plus cosine square theta, quantity d theta. So replacing cosine square theta by 1 plus cosine 2 theta over 2. So yg equals h over 4 pi. after we simplify this part. Quantity 1 minus cosine theta, then plus 1 plus cosine 2 theta over 2, the identity of cosine squared theta. So we have here 1 plus 1 half, that's 3 halves. So yg is h over 4 pi. Then quantity 3 halves of theta, integral of 2 cosine 2 cosine theta is so minus 2 sine theta. Integral of 1 half cosine 2 theta is sine 2 theta over 4. Sine 2 theta over 2, then because there is 1 half here, so times 2, so 4, denominator 0 to pi. So with our experience, these two terms will be 0. Sine of pi is 0, sine of 0 is 0. Sine of 2 pi is 0 also. Sine of 0, 2 times 0 is 0. So the whole of this is 0, and this is 3 halves of pi. So 3 halves of pi times h over 4 pi, cancel pi, so that would be 3/8 of h. So yg is 3/8 of h. So we have to memorize this. So yg is 3/8 of h. So we have to familiar with that, because for composite sections of this truncated cylinder, then we can use this formula for the location of centroid. That would be the distance along h from the base, circular base. Then by symmetry, g sub z is 0. By symmetry, g sub z is 0, so we only need xg this time. So pi r square, pi r ht xg equals integral 0 to pi of x sub c, which is just x, and x is r cosine to theta. dv is 2r d theta yt, so 2r d theta yt. Simplifying, pi r ht xg equals 2r square, then integral of cosine theta, then y, this is the y, then d theta. Factor out r, so we can cancel r, and 2. So pi r ht xg equals r squared t, r squared th, integral of cosine theta times 1, so cosine theta times cosine theta, so cosine squared theta d theta. And again, we replace this by 1 plus cosine 2 theta over 2. So xg is r over pi, after we simplify this part, from 0 to pi of cosine theta, integral of cosine theta minus 1 plus cosine 2 theta over 2. So xg is r over pi, we have sine theta minus theta over 2, then minus sine 2 theta over 4. Integral of this part from 0 to pi. So remember, sine theta, sine of pi 0, this is 0. So we only consider negative theta over 2. So this is negative pi over 2 times r over pi. So xg is negative r over 2. And as I said, g sub z by symmetry is 0. So that's it for this problem. Level 74, determine the x-coordinate of the mass center of the cylindrical shell of small uniform thickness. So we now apply the result in the preceding slides on centroid of this truncated cylindrical shell. So there are two volumes to be considered here. We have volume of this surface, which is lateral area times thickness, and the volume is circumference times height. So let's call that V1, and in this part V sub 2. So remember that this is from the result earlier, 3 over 8 of h, where h is the height of this truncated prism, which is 4r minus 2r, or 2r in that case. And that's the distance from the circular base, supposedly. So with respect to the end, that's 2r plus 3h over 8. So V1 is 2 pi RT times length 2R. So that's V1, 4 pi R squared T. V sub 2 is pi R H T. So pi R H is 2R times thickness, so 2 pi R squared T. So the volume of the material is 4 pi R squared T plus 2 pi R squared T. So that would be 6 pi R squared T. Then by Varignon's theorem, 6 pi R squared T times X sub G equals 4 pi R squared T times R, that distance is R. So 4 pi R squared T times R, then plus 2 pi R squared T, and the centroidal coordinate is 2R plus 3/8 of H, where H is 2R. So 2 pi R squared T times quantity 2R plus 3/8 of H, and H is 2R. So 6xg after cancelling out pi R squared T, the first term here is 4R, and the term here is 2 times 11 over 4R. Combining, divided by 6, so we can now derive xg, which is equal to 19 over 12 of R. So that's it, because we are only asked for the x coordinate of the mass center. Of course, by symmetry, yg and g sub g would be 0. Level 75, locate the centroid of the section shown, which was cut from a thin circular pipe by two oblique planes. So this is the figure, and if we draw it from this view here, from the x-axis, so that we can analyze, and since we already know the location of the centroid of this section, this type of section, then it's no longer a problem. So this is h over 3, 2/3 of h as given in the figure. The radius is a, and this is the y-axis, this is the z-axis. So for the location of the centroid, this is 3/8 of 2/3 h. So let's call that V1. So remember, this is 3/8 of 2/3 h of the height. So this is h over 4. Then this is radius over 2. Remember the result in the preceding slides. So this is a over 2. Then this is the center of gravity of this same shape, but height is h over 3. So the distance here is 3/8 of h over 3. So call that V2, and this is 3/8 of h over 3, and that is h over 8 from the circular base. But from the z-axis, it is h over 3 minus h over 8. Likewise, from the z-axis, the location of V1 is h over 3 plus h over 4. So that's also a over 2. This location of centroid is a over 2. So V1, or volume, is pi RHT, the general formula. So for V1, the height is 2/3 h, and the radius is a. So pi a, 2/3 of h, times t is 2/3 pi AHT. Then V sub 2 is pi a, h over 3 times t. So it is pi AHT over 3. Therefore, the combined volume is pi AHT, 2/3 pi AHT plus 1/3 pi AHT. So it is just pi AHT. Then by Varignon's theorem, volume times yg, pi AHT times yg equals volume 1, 2/3 pi AHT times the distance is, as I said, h over 3 plus h over 4, then plus V2 pi AHT over 3, the distance from the z-axis, this one is y sub c of 2 is h over 3 minus h over 8. So cancel pi aht, simplify. So yg is 7, the first term is 7 over 18h, the second term is 5 over 72h. So combining, we can now derive yg. yg is 11 over 24 of h. So that's it for yg. For xg, so pi aht g sub g is, g sub g. For x, it's 0. xg is 0. So v1, 2/3 pi ht, then zc1 is negative a over 2, as shown here, because this is the positive z direction, plus v2 pi ht over 3, then also g sub c2 is negative a over 2. Cancel pi ht, so g sub g is negative a over 3, then the second term negative a over 6. Combining, g sub z is negative a over 2. And as I said, x sub g by symmetry is 0. So that's it for this problem. Level 76, this is the last problem. Determine the x, the y, and the z coordinates of the centroid of the volume generated by rotating the shaded area about the z-axis through 90 degrees. So this is the shaded area to be revolved about the z-axis through an angle 90 degrees. So let's have a strip which is a quarter circle. The radius here is x, in that direction y, but x equals y because that's a circle, quarter circle. The thickness is dz. So that's y, which is equal to x. The thickness is dz. So therefore the differential volume is pi over 4 radius square, pi over 4 x square times thickness dz. That's the location of the centroid because this is a quarter circular area. Then the value of x sub c, which is equal to y sub c, is equal to 4 times x over 3 pi, 4r over 3 pi in general, while g sub c is just z. So this is the top view. We are positioning on the positive z-axis. So x sub c equals y sub c equals 4 times x over 3 pi, 4 times radius over 3 pi. So that's also 4, y sub c is also 4x over 3 pi. So dv is pi over 4 radius squared thickness dz. So this is the radius a, this is a minus x, that's a minus x, while this is a minus z. So the relationship a minus x square equals a square minus quantity a minus z quantity square. So a minus x is square root of a square minus quantity a minus z square. So x is a minus square root of a square minus quantity a minus z square. That's the value of x. Substitute here, volume pi over 4, integral 0 to a of a minus square root of a square minus quantity a minus z square, quantity square dz. Expanding, so let us put u equals a square minus quantity a minus z square. So u square is a square minus quantity a minus z square. So 2u du is negative 2 quantity a minus z raised to 1 times negative dz, the differential of this equation. Simplifying, u du equals a minus z dz. So from this equation here, a minus z is square root of a square minus u square. From this equation, a minus z equals square root of a square minus u square from this equation. So that dz is u du over a minus z. From this equation, dz is u du over a minus z. And since a minus z is square root of a square minus u square, so we replace a minus z by square root of a square minus u square. So we put u as a sine theta because we have constant square minus variable square. From integral calculus, we put this trigonometric substitution. Then du is a cosine theta d theta. Then with our experience, if the original limits are 0 to a, when u is 0, because when z is 0, the original variable, then u is 0. When z is a, because this is 0, when z is a, u is a. So we defined sine theta equals u over a. So this is theta, this is u, opposite, a hypotenuse. So square root of a square minus u square, this is the adjacent side, is a cosine theta also. So volume equals pi over 4 integral from 0 to a of x square. X is, or a minus u, this is a minus u quantity square. Then dz is u du over square root of a square minus u square. We expand, so volume equals pi over 4 integral 0 to pi over 2. We change limits to 0 to pi over 2. Then a minus u, which is a sine theta quantity square. U is a sine theta, du is a cosine theta d theta divided by square root of a square minus u square is a cosine theta. So cancel a cosine theta. Then we have a cube, volume is pi over 4, a cube. Then integral 0 to pi over 2 of 1 minus sine theta times sine theta d theta. We expand, volume is pi over 4 a cube. Integral 0 to pi over 2 of sine theta minus 2 sine squared theta, then plus sine cube of theta, close d theta. So remember the expansion here is 1 times sine theta, so sine theta. The second term is negative 2 sine theta times sine theta, so negative 2 sine squared theta. The last term is sine squared theta times sine theta, so sine cube theta d theta. Since the limits are from 0 to pi over 2, for the second and the last third terms, we can use Wallay formula. For the first term, we use direct integration. Integral of sine is cosine theta. Negative cosine theta, rather. So volume is pi over 4 a cube. Quantity negative cosine theta from 0 to pi over 2. Then minus pi over 2 a cube. So pi over 4 times negative 2. So negative pi over 2, then a cube. Then we use Wallay formula. So 2 minus 1 is 1. Stop. The denominator is 2. So we also stop. Then because 2 is even, then we multiply further by pi over 2. That's the rule in definite integrals on Wallay formula. For this third term, pi over 4a cube, then 3 minus 1 is 2. We stop at 2. Sum of powers is 3. Then minus 2. So 1. We stop at 1. So 3 times 1. Because 3 is odd, then we just multiply it by 1, not pi over 2. Remember Wallay formula. So this is negative pi over 4a cube. Cosine of pi over 2, 0. Minus cosine of 0, 1. So this is just pi over 4a cube. First term. Then the 0 minus 1, then minus pi over 8, pi square over 8a cube. Then next is pi over 6a cube. Combining, so volume equals, and simplifying, 5 over 12 minus pi over 8, quantity pi a cube after we factor out pi a cube. So that's the volume. Simplifying further, it is pi over 24 a cube quantity 10 minus 3 pi. So that's the expression for volume. Then by Varignon's theorem, volume xg equals integral of x sub c dv, where x sub c is 4x over 3 pi, 4r over 3 pi, so 4x over 3 pi. So volume x sub g equals integral 0 to a of 4x over 3 pi, dv is pi over 4x squared dz. Simplifying, so that would be volume x sub g equals 1/3 integral 0 to a of x cubed dz. So the value of x is again this one. So volume xg equals 1/3 integral from 0 to pi over 2. We change x cube, since x is a minus u and u is a sine theta. So remember, so a minus a sine theta quantity cube, then dz is u du over square root of a square minus u square. So this is u du over square root of a square minus u square, which is a cosine theta. So cancel a cosine theta. Simplifying, volume xg equals a to the fourth over 3 integral 0 to pi over 2 of 1 minus sine theta quantity cube. Then we have sine theta d theta. So let's expand this part. So volume xg equals a cube over 3 integral 0 to pi over 2. This is the expression we left in the preceding slide, sine theta d theta. So expand, so 1. So volume xg is a to the fourth over 3. Quantity 1 times sine theta, so sine theta. The second term is 3 times square of 1 times second term negative sine theta. So it is negative 3 sine theta, the second term, times sine theta, so negative 3 sine square theta. The third term is 3 times the first term times the square of the second term, so it is 3 sine square theta. 3 sine square theta times sine theta is 3 sine cube theta. Then the last term is the cube of the second term, negative sine theta cube, so negative sine cube theta, then times sine theta, negative sine to the fourth theta, theta. So since the limits are from 0 to pi over 2, so we can apply Wallay formula for the second, the third, and the fourth terms. The first term, we integrate this directly, and the integral is negative cosine theta. So volume xg is a to the fourth over 3 quantity negative cosine theta from 0 to pi over 2, then minus a to the fourth. So integral of sine square theta d theta from 0 to pi over 2 by Wallay formula is pi over 4, or first 2 minus 1, so 1. Denominator is 2, stop. Then because 2 is even, so times pi over 2, remember. Then we have a to the fourth over 3 times 3, so a to the fourth. So the first entry in the numerator is 3 minus 1, so 2, we stop. The denominator is sum of powers, so 3, then minus 2, so 1, we stop at 1. Because 3 is odd, so we just multiply by 1, that's the ruling. Then minus a to the fourth over 3, then integral of sine to the fourth theta d theta by Wallay formula is 4 minus 1 is 3, minus 2, so 1, we stop at 1. Exponent, sum of exponents is 4, decrease by 2, so 4 times 2, we stop at 2. Then because 4 is even, so we multiply pi over 2 further. Both 4 and 0 for cosine. Imagine we have cosine to the 0, even, so pi over 4. Pi over 2, rather. So volume xg is negative a to 4 over 3. Remember, this is positive, negative cosine of pi over 2, so negative 0 minus negative minus 1, so negative of negative 1 is positive 1. So a to the fourth over 3 first term. This is negative pi over 4 a to the fourth. This is 2/3 a to the fourth. And this is negative pi over 16 a to the fourth. Substitute volume pi over 24 a cube xg times half pi over 24 a cube, quantity 10 minus 3 pi xg. Then this one, after we factor out a to the fourth, is 1/3 plus 2/3 is 1 a to the fourth. So 1 minus negative pi over 4 and negative pi over 16 is negative 5 over 16 pi. Quantity a to the fourth. Cancel a cube and simplify xg equals yg equals 48 minus 15 pi a over 2 pi quantity 10 minus 3 pi, and that is approximately 0.2424 of a. For g sub g, volume g sub g equals integral of g sub c dv, and g sub c was just z and we have dv pi over 4x for dz. So volume g sub z equals pi over 4 integral of z, then x squared, which is quantity a minus a square root of a squared minus quantity a minus z squared dz. Expand, so volume g sub z equals pi over 4 integral 0 to a of z quantity a minus a square root of 2az minus z square quantity square dz. So it is just repeated. So expand, volume g sub z is pi over 4 integral 0 to a of z quantity a square minus 2a square root of 2az minus z square plus plus the square here. So by the way, if we simplify this, that's 2az minus z square, this one. So that's why when we expand square of the first twice the product, so that's the result after we double the product of these two, then square of the second term. So volume g sub z equals pi over 4. The integral of a square is a square z, or distribute z. So we have a square z minus 2az square root of 2az minus z square. Then z times 2az is 2az square, z times z cube, negative z square, so negative z cube dz. So we integrate this term, third and fourth, and we remember that this integral will just be 2/3. So pi over 4 a square z square over 2 plus 2 over 3 az cube minus z to the fourth over 4 from 0 to a, then minus pi over 2 because we have negative 2 here, pi over 2 a, then integral of z square root of 2az minus z squared dz. So let's focus here, but we have to substitute limits for this first term here. So volume g sub z is 11 pi over 48 a to the fourth, that's the value here. Then minus pi over 2a integral of z square root of 2az minus z squared dz. So let's call that I. So I is pi over 2a integral from 0 to A of quantity, remember Z is A minus square root of A square minus U square, then square root of 2AZ minus Z square is denoted by U, and DZ is U du over square root of A square minus U square. So this is Z, then square root of 2AZ minus Z square is U, then DZ is in other words, square root of A square minus A minus Z quantity square is U. This is the original. And we have U du over square root of A square minus U square. So I is pi over 2A, integral from 0 to A of distribute A U square over square root of A square minus U square. Then cancel square root of A square minus U square. Then we have U square here. And quantity du. So I is pi over 2A, integral 0 to A of quantity A sine theta, quantity square over A cosine theta, then minus times du, which is A cosine theta d theta, then minus pi over 2A U square. So pi over 2A, integral of U square du is U cube over 3, 0 to A. So let's cancel out A cosine theta and apply Walai formula for this case. Simplify first. I is pi over 2A to the fourth, integral of from 0 to pi over 2 of sine squared theta d theta, then minus, this is pi over 6A to the fourth. So applying Walai formula by experience, this is pi over 4, remember? So I is pi over 2A to the fourth times 1/2, then pi over 2, then minus pi over 6A to the fourth. So I is pi square over 8 minus pi over 6A to the fourth. Substitute. Volume G sub Z is 11 pi over 48A to the fourth minus quantity pi square over 8 minus pi over 6A to the fourth. Substitute volume pi over 24A cubed, then G sub Z. A cubed quantity 10 minus 3 pi G sub Z equals 19 over 48 minus pi over 8 pi A to the fourth after we factor out pi A to the fourth and combine like terms. So we have 19 over 48, 11 pi over 48 A to the fourth plus pi over 6A to the fourth. So that's 19 over 48 pi A to the fourth. Then simplifying, G sub Z is 19 minus 6 pi over 2 quantity 10 minus 3 pi. That's the simplification. You just use your calculator there. And it is approximately equal to 0.1308 of A. So that's G sub Z. So that's it for this problem.